Hi guys, welcome to the IT program here at SIIT on YouTube. This is one of several video tutorial clips that we're going to be doing. And in today's clip, we're going to start looking at subnetting. In particular, we'll look at basic subnetting. So the first thing that we can discuss with regards to this what subnetting is and why it's important. And we can start by answering that second question first. Why is subnetting an important technique? One of the issues, and the big issues with IP version 4 addresses is address depletion. IP version 4, that system of addressing was devised at a time when there were very few computers in the world. Now we have millions upon millions, literally, of hosts. And the number of addresses provided by IP version 4 is quickly running out. And so address conservation is a big issue. Subnetting, as a technique, was specifically designed as a means for conserving addresses by making more efficient use of address spaces for smaller subnetworks, or really for any size of subnetwork. So for example, if we can look at an example here. Let's say, for example, that I need 3 networks, and each network has 50 hosts in it. Now, 3 distinct networks would normally require 3 full address spaces, and even with a Class C address, which is the smallest size of address space, that's still going to waste a couple of hundred addresses in each of those networks, because I'm going to end up using one for each of those. That's a lot of wasted space. 80% of the address space is wasted. It would be nice if I could have some way that I could take, say, one Class C address space and break it up into smaller pieces and make better use of it. Because if I look at what I've got here, the grand total of addresses I need is only 150. And that's quite a bit smaller even than what the total is for one Class C address. A Class C address, network address, has 254 usable host addresses in it. And so what subnetting is going to allow me to do is break that address space up, one address space, up into pieces, smaller pieces that will better fit what I need in this case. So we can pick whatever we want. We'll say 192.168.100.0 will be the address space we're going to use, and we're going to split it up into pieces big enough to accommodate those 3 networks. Now, there's some rules in how we can go about doing this. One of them is we can't choose any arbitrary size network to split our address space up into. We're limited in that when we break up a network into subnets, that each subnet has to be a binary size. And the number of subnets that we can create is also binary sized. And we'll see why that is when we start calculating this. Now, what we do, recall from our discussion of IP addressing, the structure of an IP address is such that we divide it into roughly 2 sections. Just do that here. The leftmost bits are the network bits. Those bits, the combination of them, uniquely identifies a particular network. The rightmost bits are the host bits. The host bits, or the host bit combinations, uniquely identify a particular host within a particular network. What subnetting allows us to do is to use a portion of the host bits to specify a particular subnetwork within the larger network, or in effect, to divide it up into smaller pieces. So we'll look at how we can go about doing this. In our case, we're using a Class C address. And so the only bits that we're going to work with, and this applies to all classes, A, B, or C, the only bits that we work with and manipulate are the host bits. So we can pretty much forget about our network bits altogether because they're not going to change at all. The only bits that we'll be working with are the host bits. So a Class C address, that's the final octet that are the host bits, 8 bits. And we just leave the original network bits, the first 24, we just leave them alone altogether because we're not going to be doing anything with them. And so what I'm going to do is I'm going to specify, starting at the left, some number of bits that I'm going to borrow to subdivide this network into smaller pieces. Now, there's some different conventions for how these things get labeled. So originally we said network bits and host bits. Some explanations will keep those two and just state that the bits that are borrowed just simply become network bits. And so you still just have network bits and host bits. Other explanations will create a third category where they'll say the network bits are the original network bits. The host bits are the host bits that are left after you're done. And whatever you borrow are referred to as subnetwork bits. For my explanation, I'm going to use the latter form. The reason I'm going to do that is because I like the idea, especially when you're starting out, of being very specific about what bits we're referring to. And there are sort of 3 different types of bits. The original one, network bits, the bits that we borrowed to create our subnets, and then the remaining bits that are used for host addresses. So I'm going to actually use those 3 categorizations for the bits. So our network bits we don't touch, and I'm actually going to write that up here. So the first 3 octets we leave alone. The last octet, what we need to do is to divide it up into pieces that are big enough to accommodate that. Now, a couple of different formulas that we can use for this. We can figure out how many subnetworks we can create using one formula, and we can use another formula to specify how big the subnets are, how many hosts there are per subnet.